project that we're doing at Bangor University in chemistry. I'm Patrick Ward.
I'm Daniel Connah.
I'm Tom Lees.
And I'm Matthew Ellis.
Thanks for watching.
Guys, my third year project is looking into biodegradable polymers. Basically, they are made of a PEG, which is a polyethylene glycol group, which likes water, so hydrophilic, and a dilactide group, which doesn't like water and hydrophobic. Basically, this means that they can be injected into the body and it isn't soluble, so it can hold tissue and stem cells to grow new bone marrow and any living tissue on it. Over to you, Matt.
Thanks, Dan. Well, basically, my project is to look at DSCs, which are dye-sensitized solar cells. More importantly, the glass which they're made out of. Basically, dye-sensitized solar cell is like a solar panel, but it uses dye on the inside. As the sunlight hits the dye, this excites an electron, shoots up, works into, say, a motor or some kind of electric power load, back in through the bottom of the cell, into the electrolyte, and back into the dye, and this can recycle itself to create electricity. Over to you, Tom.
Thank you, Matt. Hi, I am synthesizing light-emitting polymers. In your LCD TV, electric current is run through a polymer and that emits a colour like red, green or blue. I'm trying to synthesize a polymer that releases blue light. The problem with blue is that it takes a lot of energy to release it, and that tends to burn out or break down the polymer. So I'm trying to synthesize one that lasts a lot longer and emits the blue light. Over to you, Paddy.
Cheers, Tom. Hi, I'm here to talk to you about boranes and my chemistry project of my third year. This is diborane. I'm doing computational chemistry based project using aim analysis of 3 electron 2 center bonds. As you can see, they look like a banana. Cheers. Over to you, Dan.
Thanks, Paddy. So why is it important? Well, basically, nobody knows how to recreate bone at the moment, and everybody's breaking bones, having new hips, and they're being put in with metal. Metal doesn't degrade, and metal doesn't stick to the bone. If you use a polymer, you can put stem cells into it, which will help the bone grow on it and create more adhesion to, say, a new hip. You can also grow cartilage on it, and this can help in the body where you've lost it. Over to you, Matt.
Cheers, Dan. Why is it important? Well, basically, I'm looking into sintering the metal oxides on the plate at a much lower temperature, around 150 degrees. This will enable us to maybe put it onto plastic, making these cells out of plastic, which will then enable people to have more solar panels on their roofs for a cheaper price, as this will cut the cost by 40 to 50%. Over to Tom.
Thanks again, Matt. Okay, the reason it's important is, in this day and age, with technology being so important, if I can make a polymer that emits blue light more efficiently, more durably, at a cheaper cost, then it's going to not revolutionise TVs, but it'll help. Over to you, Paddy.
Well, Tom, my project's important because basically nobody's ever found out the real details of large molecular boranes. So, diborane in itself is highly unstable, so it's very hard to analyse in a lab. Using computer programs, aim analysis, my project, we can find out much, much more than we could in experimental stuff. Cheers!
Thanks for watching. Bye. Au revoir. Somebody close the door.
So,